Okay, radians. So we're going to start the trigonometry unit. Radians. So in the past, we've told you that we measure angles with degrees, but there's a better way to do it. So I'm going to just quickly go through the history of what's going on here. So first of all, let's define angle. What is an angle? An angle is two rays that start at the same point, and that's called the vertex. So that's an angle. And then the two rays, we have the initial ray, and the terminal ray. Okay, so the idea is, how do we measuring an angle, and that is the distance that the terminal ray moves from the initial ray. So it's the distance, the rotation, the terminal ray moves away from the initial ray. So let me get another pen because this is running out of ink. So, for example, here's my initial ray, here's my terminal ray. So here's the initial, here's the terminal, and from when when you were a kid younger and you use the protractor and you measured an angle, you put along the initial, and then the idea is that the terminal ray moved away from the initial ray. So, and the idea is we're going to call the angle positive if it goes counterclockwise or anti-clockwise, and we're going to say the angle is negative if it's going clockwise. Once again, counterclockwise, clockwise. And so we know that a full rotation, we call it 360 degrees. So if it goes all the way around, we say it's rotated 360 degrees. We say a half rotation, we call it 180 degrees, right? And then 1/4 of a rotation. And once again, we're going to say this is counterclockwise, so this is 90 degrees, so it's a quarter rotation, and 3/4 of a rotation is 270 degrees. Okay. Another term you might have used in the past is the word coterminal. Coterminal, and a coterminal. So two angles are coterminal if the initial and terminal ray occupy the same space. So for example, how about, we have, this is an initial ray, and this is the terminal ray. Let's say that So for example, this angle is a positive 135 degrees, but you could also say, if I went clockwise, negative 225 degrees, it's kind of like the same angle. Once again, the initial and terminal occupy the same space. You could also say, for example, here's your initial, here's your terminal, and you could say 45 degrees is coterminal with 415 degrees because they're like at the same place. So you've done all the things with angles. The sum of the angles of a triangle is 180 degrees, and complementary angles are the sum is 90 degrees. But the question we have to ask ourselves right now is, where did the 360 come from? Where did where did the 360 degrees come from? So I want you to pause the video, and I'd like you to explore that. Like, where did they get 360 from? Okay. So, in class we'll talk about maybe stuff you probably, but we need a better way, because the word is arbitrary. That's the word, and so, they kind of came up with a rule, but like, we don't know where they got it, so we need something better. We need something more, we need a better way to measure an angle. And so what we're going to do is we're going to use something called radians. Now, the idea is, let's develop into it. You can take notes, or you don't have to. Obviously, we're going to get to a formula at the end. I'm just going to take you through it. So, how are we doing for time? 6 minutes, perfect. Okay, first of all, circle. What is a circle? It's a set of points equidistant from a fixed point. We call it the center. Equidistant from a fixed point called the center. Okay, definition 2. What's an arc? An arc is a part of the circle. Part of the circle. And the idea is, and what's the radius? What is the radius? No, it's not half the diameter. Well, I'm not going to get into it. I'm just going to say it right now. A chord is a segment that connects 2 points on the circle. A diameter is a chord that passes through the center. And a radius, whose measurement is half the diameter, a radius is a segment that starts at the center and ends up on the circle. So it's a segment whose endpoints are the center and a point on the circle. You don't really need to know it for this class. I just want to kind of just go through this. And we can put let's see. So we can put the angle inside the circle. So we can put an angle inside the circle. This is going to be, we're developing the entire basis of trigonometry here. And so a central angle is an angle whose center is, I apologize. A central angle, is an angle whose vertex is the center of the circle. Nice. So let's get a diagram up. We have a circle. It's not the best circle, but I'm not an art student. So we have a circle. And the idea is I'm putting this is my circle, and this is the center, we'll call it O, and I'm putting angle AOB in the circle, so it's a central angle. The other thing you learned in a previous class might be inscribed angle. Look that up. Inscribed angle. And that's an angle whose vertex is any point on the circle. But I want to look at the central angle here. So the next thing is subtend. I'm not going to define this word. I'm just going to use it in a sentence and just tell you that arc AB is subtended by angle AOB. So I want you to visually see what's going on. It's an old word. We really don't use it anymore. But the idea is that an arc is subtended by an angle. Right? Good. Let's move on. Now, what we're going to see is that, so what I want you to do is we know that this is the terminal ray, and this is the initial ray, initial ray. And what we're going to see is that and the angle is right here, and what we're going to see is that as the terminal ray moves around the circle, there seems to be a one-to-one correspondence between the angle measurement and the circumference, or the measurement of the arc. There's a relationship, okay? So we notice, I'll put it over here. Let's see, we erase this. Sorry, so we notice that there is a one-to-one relationship between the rotation and the subtended arc. And that's the circumference of the circumference of the circle. Circumference of the circle. And so with a radius of 1, we're going to start with a radius of 1, and we're actually going to use a radius of 1 for like the rest of the trigonometry. We're good for time. With a radius for 1, it seems that 360 degrees seems to correspond to the circumference of the circle of 2 pi, right? Because if the circumference is 2 pi r and the radius is 1, it seems that like when we rotate 360 degrees, we sweep out the full circumference. Or like when we do 180 degrees, when, this goes 180 degrees, it seems like we sweep out pi, right? And so some of you might say, oh, Mr. Adler, we learned last year that 180 degrees is pi radians. Good. So, but this is where it comes from. So we're there. Let's just take it another step, just in this first lesson. Obviously, I'm only going to be asking you in the exercises, convert degrees to radians and convert radians to degrees. Well, let's talk a little bit more. Let's just develop this a little bit more. 90 degrees seems to correspond to pi over 2, and 270 degrees corresponds to 3 pi over 2. Once again, if I do 3/4 of the way around, if my rotation is 3/4 the way around, it seems to correspond with 3 pi over 2. Okay? And so once again, this is the connection. You learned it last year. Maybe the idea is 180 degrees is pi radians. And so we can see here that, we see here, so we have, where's my pen? Sorry about that. So we know that degrees to radians is 180 degrees to pi, and this was what you used to convert last year. So for example, if I say convert 70 degrees to radians, you would say, okay, 70 over r equals 180 over pi, and you would solve for, you say 180 r equals 70 pi. So, 7 pi over 18 radians is like 70 degrees. Or I might say convert 2.4 radians, right? And so, you say, well, what's 2.4 radians? Well, 2 pi, which is 6.28, that's, 360 degrees. So 3.14 radians is 180 degrees. So 2.14 radians is somewhere between, pi, or for example, pi over 2, which is 1.54 radians, or pi over 2 is 1.54. So 2.4 is somewhere between 90 and 180, or pi over 2 and pi. Let's see. So we have degrees over 2.4. I'm sorry, that's 2.4 radians. And I want to convert that into degrees. Once again, I know that pi radians is 180, and I know that which is 3.14. I know that pi over 2, which is 1.57, that's 90. So I know 2.4 radians is somewhere between this. Just use the so let's see, d over 2.4 equals 180 over pi. And so we have d is equal to 180 times 2.4 over pi, which is about 137. Good. What is 1 radian? What does that mean, 1 radian? Well, it's if a radian measure, like degrees, 1 degree, 1 year, 1 mile. So what is 1 radian? Well, it turns out that 1 radian is actually the angle in which the arc length, the subtended arc length, is equal to the radius. It's kind of interesting, right? So the idea is based on the definition is that there's some connection between the arc length and the radius, which you learned last year. So let's explore that a little bit. So what I want you to do is, so, and you can manipulate the numbers, so let's see, degree over 1 equals 180 over pi, and you get d equals 57.26, right? So I want you to, good. What I want you to do, good. Okay, so we found out that 1 radian is 57.6 degrees. So I wanted to explore something else. So what we're going to do is we're going to put in we're going to put a circle in. So we're going to scroll down, right? Let's go to circle with center. So the center is going to be 0, 0. And let's just put it anywhere you want it to be, anything. And then what we're going to do is come back up, and I'm going to put a point on the circle right there. Nice. Now let's move. Okay. I'm going to shrink it a little bit, right? And so what I'm going to do is first I'm going to create some segments because I want to create angle CAB. No. Whoops, sorry. Let's construct a segment. Let's go to CA. And then we're going to go to CB. Whoops. Let's see. C over to B. Nice. So we have our initial ray over here and our terminal ray over here. Let's go back to move. And the idea is I want to measure 2 things. So I can move C along my circle, and I want to move it so it's 57 degrees, which was 1 radian. And so first of all, how do I measure the angle? Well, I kind of have to go in a counterclockwise for positives. So when I scroll down to GeoGebra to measure the angle, I have to start at B, move to A, and then go up to C to get that angle in the inside. Because if I went CAB, it would be like the big angle, which isn't what I want. Okay, let's go back to move. And I want to move, I'm going to move C around. So I get, what did I say? It was 57.2-ish, right? 50, perfect. That's good enough. That's fine. Okay, we're going to explore two things. This is kind of interesting. What I want you to do first is I want you to measure the radius of the circle. So let's look at OB. So let's see, measure, click on OB, 6.7. Whoops. And you can see that, let's move this down. I can move B wherever I want. Everything stays, but it is the 57.29 stays. This is kind of cool. Actually, this is perfect. The next thing I want you to do is I want you to measure this arc length. Now, it has a length. You could walk along from B to C. It has a measurement, right? So what is that measurement? Well, what we're going to do is we're going to measure the arc. Let's find that. Let's find this. Let me close this more. Where do we find, how do we measure the arc? Let's see. Circular arc. So select the center and 2 points. B, C. Oh, I did it the wrong way. So let's undo that. Let's start over again. Let's go back here. Let's go down to the bottom. More. And we want to measure circles. We want a circular arc. So we want to select the center. And then B to C. We got D. And then the idea is I want to measure D. Well, let's see what D, let's see if we have it here. 5, nice. Well, what do we notice? So let's see, can I get the measurement there? Let's see, duplicate show settings. Well, let's leave this open. So we know, 5, not a coincidence. Interesting, that the arc is equal to the radius. Maybe that's a coincidence. Maybe I just happened to find that one circle. Let's move, let me go back to move. Let's go back to move, okay? And then let's go to the calculator, because I want to see the relationship between the arc and the radius. Let me move B around. And what do you notice is that for 1 radian, the arc is always equal to the radius. Let's move it around some more. Let's make it really small. 2.3, 2.3. And so the idea is what we want to explore is that there seems to be a relationship between to measure an angle here, there's a relationship between the arc and the radius. And so we're going to explore that in a second. Let me get out of the video. And let's see. And what you can do is you can try to find, you can make many for example, so let me go back, let me put this back. What you can do is, why don't you move C so that the angle is 90 degrees. Let's get it perfect. I can't get it perfect. And I want you to explore with the many different circles, the relationship between the circular arc and the radius. So this circle, it's supposed to be 90 degrees. Move B over, here. And what's the relationship between the arc and the radius? Maybe move it even smaller. What's the relationship between 90 degrees and 2.63 and 1.4? And then over here, the same 90 degrees and 10.84 and 6.8. See if you can come up with some relationship. And then I want you to see if you come up with a general relationship for finding the radians, to measure an angle using radians. Good. Okay, so in the video, I just asked you to kind of explore the 90-degree angle and the relationship between the subtended arc and the radius. Let's just take a quick look at that. So let's take a look at radius 1. Here's a circle. And so here's the right angle, right? We know that the full circumference is 2 pi. Therefore, for 90 degrees, if the radius is 1, and we know the subtended arc is pi over 4. No, pi over 2, because 2 pi divided by 4, is pi over 2. Okay, let's take a radius of 3. Same circle. but radius of 3. We know the full circumference is 6 pi. Therefore, this is 3 pi over 2, right? And last circle, how about we do, 8, radius of 8. And so we have 8, and we know the full circumference is 16 pi, and therefore the subtended arc is 4 pi. What you all should say is, hey, Mr. Adler, in all 3 cases, for every 90-degree angle, we see that the ratio of the subtended arc over the radius is the same in all 3 cases. This is why we use radians, because it's very clear, and it's very straightforward, and we can prove it that this relationship holds all the time. Once again, 360 is a great number. I love it, love it, love it. But we don't know where they got it, and it's really not the best answer how they got it. We'll use it. I use it all the time, but this is more, this is more clear. If we call the arc length S, some books use L, and we call the radius R, it turns out that S over R, pi over 2, over here, 3 pi over 2 divided by 3 is pi over 2. And the same thing over here, 4 pi over 8, which is pi over 2. We can say that now this is a better way to measure angles by using radians. So this 1/4 of a rotation, we say is pi over 2. Now, sometimes people write radians, but it's a unitless measurement. It's kind of one of those weird things. It shows up like physics has a couple of those. So you can either write pi over 2 or pi over 2 radians. So we saw in the previous lesson, so 2 things. We have this relationship. The measurement of the angle is equal to the arc length over the radius. Okay? So you're going to see some questions like that. That's the idea. Also, we saw that 180 degrees is equal to pi radians. So these are the 2 lessons you need to walk away from. Once again, this is arc length, and this is the radius. Now, I'm gonna need you for the next couple of lessons to remember the unit circle. But once again, this is how the measurement of an angle is the arc length over the radius, and 180 degrees is like pi radians. Good.